Hello guys, today we're going to be solving the two-sum LeetCode problem. So, given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice, and you can return the answer in any order. So for the first example, we have the input of nums, which contains 2, 7, 11, and 15, and target of 9. So in this case, the two numbers that add up to 9 are 2 and 7, which are located in indices 0 and 1, which is what the output is. For the second example, we have nums as 3, 2, and 4. Target is 6. Two numbers that add up to 6 are 2 and 4, which are located at indices 1 and 2. For the third example, the nums is 3 and 3, and the target is 6. Two numbers that add up to 6 are obviously just the two numbers that are located in the array, which are 3 and 3, which are located in indices 0 and 1. So we have to remember that you may assume each input has exactly one solution. So we don't have to check for cases where it has no solutions or has multiple solutions, and you may not use the same element twice. So that means, for example, for here, the list is 3, 2, and 4, target is 6. We can't return 0, 0 since 3 plus 3 is 6. So in this video, we're going to be talking about the brute force solution to doing this, which requires an O of n squared time complexity. So this one is fairly simple. All you do is iterate through the list for I in range len of nums, for j in range. So for j, since we don't want to use the same element twice, we'll start at I plus 1 and go to len nums. So, and then we just check if nums I plus nums j is equal to target. We return the indices of both I and j, and it says you can return the answer in any order, so we can just do it like this. This returns an array containing I and j. So let me just run through the array with this code so you guys really understand. So nums starts at 2, 7, 11, and 15, and we iterate through the list with I, so I would be 2 in this case. Then we iterate through j, where j starts at I plus 1, so it starts at index 1, which is 7. We start at 2, we go through each one. We first go to this, we add up these two numbers. Is it equal to target? Yes, it's equal to target. So we return ij, which is the indices where 2 and 7 are located, which is just 0, 1. Now let's submit this. Yeah, so although it runs at 2032 milliseconds, and time complexity is O of n squared, so it's not the most optimal solution, but it still works.